Square root of x. Giving a non-negative integer x, return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. You must not use any built-in exponent function or operator. For example, do not use power function in C++ or Python. For example, if we have input 4, since square root of 4 is 2, we return 2. If the input is 8, then square root of 8 is 2.82842, and we will round it down to the nearest integer, so we return 2. And for this question, I'm going to use a binary search approach. And first, I'm going to have some edge case check. So if x is less or equal to 1, then I will just return x itself, because for example, when x is 1, square root of 1 is 1. When x is 0, square root of 0 is 0. Next, I will set up my binary search, so I will have a start point. I will initialize to 1. I will have an end point. I will initialize it to x divided by 2, because square root of any number will not greater than the number divided by 2. Also, I think it's better to set the variable long, because as we can see, as in the question, it might be a big number, so we don't want to have integer overflow problem. And then I will have a while loop, so I will say as long as start doesn't exceed the endpoint, so I will say as long as start is less or equal to end, I will keep the iteration. Inside, I will have a variable called mid, which is the midpoint in our range. So the midpoint, I will set it to start plus end minus start divided by 2. And then I will use if statement to check, and then I will first get the square of midpoint number, and then I will check if that number is greater than the x, then we know the midpoint is too big. In that case, we want to lower our ending point, so I will say end equal to mid minus 1. Similar logic, if square of mid is less than x, that means we know the midpoint is too small. In that case, we want to move up the lower bound, which is the end, so I will say we want to move up our starting point, so the start equal to mid plus 1. And then else, the only possible condition will be when the square of mid is equal to x. In that case, we found our answer, so we will just return mid. But since the question needs return to be integer type, so we will cast that midpoint to the integer. And then if the while loop breaks, that means we found our answer. We will just return end, so I will cast that to integer type, and that's the code. Next, the time complexity will be O of log n, because binary search will eliminate half of the possible answer for each iteration, and the space complexity will be of 1, because we create a few variables and then it's using constant space. Next, let's test this code out. Looks like we passed the test.